Good day, my name is Brenda Leong with entry number 73382, and our group members are Jun Yong, Adeline Amira, Noor Hidayah, and Muhammad Shareh. Today we will be presenting our project on the fuel cell mower. I will begin with the basic functions of mowers. Mowers cut grass using high-speed rotating blades or strings, making it easy to maintain a neat and well-kept lawn. There are two common types of mower, which are reel mowers and rotary mowers. The invention of the lawnmower dates back to 1830 thanks to Edwin Burt Budding. He designed the first mower after being inspired by a machine used to smooth cloth in textile mills. Early mowers were made of cast iron and featured a rear roller for stability, reflecting the ingenuity of early industrial design. There are six types of modern variants for mowers. Firstly, reel mowers provide a crisp cut with their scissor action, making them environmentally friendly, quiet, and requiring minimal maintenance. They are an excellent choice for small to medium-sized lawns. Rotary mowers, powered by either electric motor or internal combustion engines, release cut grass through an opening. While robust and efficient for larger areas, they are not as eco-friendly as reel mowers. Next, electric mowers are available in both corded and battery-operated models. They are quieter, emission-free, and cleaner compared to gas-powered mowers. They offer a modern solution for environmentally conscious homeowners. Next, gas power mowers are highly effective for cutting thick grass and managing large properties. However, they require more maintenance and are less environmentally friendly due to the emission. The riding models are designed for extensive lawn. It significantly reduces mowing time and physical effort. They come in various types including land tractors, zero-turn mowers and rear-engine riding mowers, each suited for different purposes. Lastly, hover mowers operate on a principle similar to hovercraft. They float above the ground, making them particularly effective for managing uneven surfaces, inclines, and irregularly shaped lawns. Now let's talk about the future mowing technology, which is the fuel cell mowers. These innovative machines are an excellent alternative to traditional mowers, offering high efficiency, silent operation, lower weight, and zero emission. Fuel cell mowers use a combination of hydrogen and oxygen to produce energy, employing a proton exchange membrane fuel cell for optimal performance and conductivity. Next, the mower design will be discussed. The first part is the blade system of the mowers. There are five types of blade commonly used in the mowers. The high leaf blade is suitable for cutting tall and flimsy grass due to its high suction level, which ensure no grass accumulate in the shoot, thus preventing damage. However, this blade type requires high power to generate the necessary suction. The low leaf blade is ideal for cutting short grass and perform well in sandy soil conditions. It has low suction level, which means it requires less power to operate. Next, the getter blade is best used for overgrown grass. It has a high suction level and its unique getter teeth design continuously push the grass towards the sharp cutting edge as the mowers move. While this blade is excellent for fertilizing soil, it is not suitable for use in sandy soil conditions. The mulching blade is designed for cutting grass into fine pieces, which can then be returned to the soil as natural nutrients. This blade, also known as three-in-one blade, features curvier edges suitable for this purpose. However, it is not ideal for cutting dense grass as it can potentially damage the mower deck. The flatbed blade has the high suction level, making it well suited for cutting dense grass and operating effectively in sandy soil conditions. This blade system is considered the most suitable overall due to its versatility and efficiency in various conditions. The fuel cell technology represents a significant advancement in powering lawn mowers. It converts hydrogen or methanol directly into electricity, providing a clean energy solution with water as the only byproduct. There are several types of fuel cells, including alkaline fuel cells, phosphoric acid fuel cells, molten carbonate fuel cells, solid oxide fuel cells, polymer electrolyte membrane fuel cells, and direct methanol fuel cells. For this project, the polymer electrolyte membrane fuel cells was chosen due to its high power density, scalability, rapid startup, and numerous environmental benefits. Modern lawn mowers often feature a self-propel system, which significantly reduces physical effort by using a motor to drive the wheels. This system is especially beneficial for large lawns or those with uneven or inclined surfaces, providing enhanced convenience and reducing user fatigue during extended mowing sessions. A sophisticated height adjustment system is essential for optimal lawn care. This system allows users to easily adjust the mower deck's height using a pedal or lever, enabling them to choose the preferred cutting height. This functionality ensures a customized mowing experience suited to different grass type and lawn conditions. For the design materials, the flat-shaped blade is crafted from steel alloy, which is selected for its durability and toughness. This material ensures the blade can withstand the impact and pressures encountered during the mowing, such as hitting rocks or uneven surfaces, thereby enhancing its longevity. The mowing deck is constructed from polymer composite materials. This choice significantly reduces the weight of the mower compared to traditional steel decks, improving mobility and requiring less power to operate. Additionally, polymer composite offer excellent resistance to corrosion and rust, ensuring the deck maintains its appearance and structural integrity over time. Large knobby tires are used for the wheels to enhance the mower's stability across various terrains, including wet grass and uneven surfaces. These tires feature deep treads with visible lugs or knobs, which provide superior grip and traction, preventing slipping and sliding, and ensuring efficient and safe moving across the surfaces.
Hello, I'm Muhammad Sarif bin Sophia and I will present the proper design of the land mower. The figures show the proper design of the land mower with various views to highlight the key component and the overall structure. For the first view, which the rendered view of the proposed land mower, this view provides a comprehensive visual of the land mower, which highlighting the field cell casing, which positioning prominently on the body of the mower. The design emphasizes the integration of the hydrogen fuel cell system with the mower traditional structure. For the top view of the proposed land mower, the hydrogen storage tank is clearly visible at the rear of the mower. This placement ensures that hydrogen fuel is stored securely and efficiently, which providing the necessary energy to the power of the mower operation. Thirdly, the bottom view of the proposed land mower, which was focusing on the underside of the land mower, where the cutting blade and the wheel are prominently displayed. The cutting blade is positioned centrally to ensure the effective grass cutting, and the wheel are strategically placed to provide the stability and ease of the movement. But not least, the front view of the proposed land mower is show the motor casing, which house the motor responsible for the driving, the cutting blade, and the other mechanical component. We highlight the streamlined design that protect the motor while maintaining is for maintenance. Next, design calculation and formulation. For this part, more focusing on the design of the cutting blade, which including the area of the blade, volume and mass of the blade, weight of the blade, torque, angular velocity, power generated at the blade, and lastly, the centrifugal force. For design of the deck, we have diameter, height, load, length of the spin hook. For the calculation, we have the yield stress, ultimate stress, allowable shear stress, bending moment, and lastly sectional modular Z. Next, I will present the fuel type property, which consists of five properties, which is the high calorific value, high efficiency, minimal environmental impact, attainable ignition temperature, and the low maintenance cost. But the high calorific value refers to the amount of energy produced by the complete combustion of the unit of fuel. This is to determine the efficiency of a fuel. High efficiency refer to the direct conversion of the chemical energy to the electrical energy is not limited by the kinetical constraint. Minimal environmental impact more to the lower emission of the CO2 and NOx per kilowatt. It's a better efficiency and lower fuel oxidation temperature and minimal noise and vibration due to the fewer moving part. Attainable ignition temperature refer to the ideal range to ensure the safety and ease of the ignition. And lastly, the low maintenance cost ensure the high modulity allow for the easy location and replacement of the faulty cell and reduce the maintenance expenses due to the simplicity in the cell replacement. Next, for the primary component consists of three, which are the electrolyte, electrode, and catalyst. For the electrolyte, refer to the membrane restricting ion flow and transmit the proton in the PM fuel cell. For the electrode, there are two electrodes, which is the anode and cathode. Anode refer to the negative pose where the hydrogen split into the electron and proton, while the cathode positive pose where the oxygen combine with the proton and electron to produce the water. Last but not least, the catalyst, which is coated on the both anode and cathode, typically made of the platinum and used to speed up the chemical reaction. For the evaluating performance, there are two for the electrolyte and the three for electrode. For the electrode, there are proton conductivity, which refers to the high conductivity, lower internal resistance, and increase the efficiency. For the durability, must withstand for the temperature, humidity, chemical stability, and mechanical state without the degrading. For the electrode, their catalyst activity show the high activity at the electrode increase the reaction rate and enhance the performance. For durability, long-term performance can be affected by catalyst deterioration from the corrosion or oxidation. And lastly, the poisoning resistant. Catalyst show resist poison. For example, carbon monoxide reducing the catalyst efficiency.
The heat management system that involved in this mower is the thermal management system, whereas this is essential to maintain the thermal equilibrium in this fuel cell. Therefore, in this project, we are using hybrid nature of the system dynamic that facilitated by two position, three-way valve that can manage the power distribution between the fuel cell stack and also the energy storage unit. The essential of having this efficient heat management is firstly because of the electric energy produced from the interaction between the hydrogen and also the oxygen through the electrochemical process. However, it can produce heat and also water as the byproduct from that process. The heat of the electric pump also regulate the coolant entering the stack. This factor can also contribute the heat transfer to or from the stack that can contribute to the heat that can cause the overheating in the fuel cell. Additionally, another application to prevent overheat by emerging the liquid cooling for the heat exchanger in the high power automatic fuel cell stack. The heat management is important not only to prevent overheat but also to prevent any possibility locals such as dryness and also degradation of the electrolyte membrane due to the evaporation that may happen gas phase water within the membrane. Next, for the water management, it's important to maintain the optimal water content within the membrane for the efficient fuel cell operation to avoid the membrane from dehydration. This project, we're using the electro-osmotic track to pull the water from the anode to the cathode. This is because the water that accumulated at the cathode catalyst layer can cause obstruction of the gaseous oxidant access to the reaction surface. This can limit the stack of performance. The techie and economic aspect in terms of economic control mechanism also safety that involved in this project. Firstly is the economic. Even though hydrogen is expensive compared to the conventional gasoline, hydrogen has higher efficiency and lower emission. Hydrogen is still better than conventional gasoline because hydrogen can store energy more and also need lower maintenance due to fewer moving components and also experience less wear and tears. Fuel cell mower undergo an electrochemical process as discussed in the previous slide. The electrochemical process to turn hydrogen into electricity, which drive the mower blades compared to the combustion engine. Next, for the control mechanism. This control mechanism is essential for this mower is because it can operate at high performance of PEM fuel cell. The sensor track that we are using for the temperature management to avoid thermal stress and also eliminate heat produced during the operation as discussed in the heat management part. The sensor track used to send information to automate control systems so they can modify heat dissipation and also cooling power mechanism as necessary. This can extend the fuel cell life by power management that use mass flow controller and also the valve. Lastly, for the safety, in order to store the hydrogen safely, the safety valve are incorporated into the hydrogen tank and construction to the guard against the leaks and also rupture and to resist heat pressure. This system monitoring can be turned off if dangerous are recognized by sophisticated sensor and also the control system. The use of fuel cells only operate at a low temperature, hence lower possibility of burn that could occur. This makes the fuel cell is safer compared to the gasoline combustion.
The safety aspects that need to be considered is storage of hydrogen. It is essential to store hydrogen safely. Safety valves are incorporated into hydrogen tanks construction to guard against leaks and ruptures and to resist high pressures. Next, the system monitoring. This is essential to identify any irregularities early on. The fuel cell system must be continuously monitored. The system can be turned off if dangerous situations are recognized by sophisticated sensors and control systems. Lastly, low operating temperatures. When compared to internal combustion engines, fuel cells typically operate at lower temperatures, which lowers the possibility of burns and heat related mishaps during upkeep and operations. The performance evaluation of mower design focuses on key functional elements to ensure high standards and user satisfaction. Cutting efficiency is crucial, which refers to the mower's ability to cut grass cleanly and evenly. The shape of blades, which are more sharp and high quality blades, provide a precise cut which directly minimizes missed spots and reduces the need for multiple passes. Therefore, the grass was cut have great looking lawn and enhanced the health of the grass growth. Apart from it, power and fuel efficiency are also important, involving the mower's power output and its fuel of battery usage. Efficient power ensures the mower can handle thick grass without bogging down, while fuel efficiency lowers operating costs and environmental impact. Our engines are optimized for fuel consumption and emissions, which electric models offer quiet, eco-friendly performance with long-lasting battery life. Next, maneuverability and ease of use encompasses how easily the mower can be moved and controlled, especially around obstacles, and the overall user friendliness. The specification of lightweight and well-balanced mowers can make significant impact to the maneuverability of mower. High quality wheels also ensure smooth movement across various surfaces and a tight turning radius aids in navigating around obstacles. Performance in varied conditions assess the mower's ability to operate under different environmental and terrain conditions, such as wet grass, uneven ground, and various weather scenarios. It is important in order to maintain the consistency of mower performance on all terrains and in diverse weather conditions. They adapt effortlessly to different terrains, maintaining consistent performance, whether on flat lawns or steep slopes. The robust design handles obstacles like tree roots and rocks which with ease, ensuring a smooth cut. Additionally, the mowers perform admirably in diverse weather conditions, cutting through wet grass without clogging and operating reliably in extreme temperatures. This versatility ensures that the mower delivers exceptional performance, efficiency, and user satisfaction, making lawn care more efficient.
Now, let's dive into the key elements that ensure our mowers operate at peak efficiency while preserving its longevity and reliability. Firstly, our mower incorporates a PEM fuel cell power source, renowned for its efficiency in converting 60% of hydrogen's chemical energy into usable power. To maintain optimal performance, we implement rigorous heat management, crucial for keeping the operational temperatures between 60 degrees and 80 degrees Celsius. This prevents membrane degradation and ensures consistent efficiency. Secondly, effective water management is pivotal. Maintaining humidity levels above 80% promotes efficient proton transport, essential for the fuel cell's operation. However, balancing water levels is critical to prevent flooding and channel blockage that could impair performance. Our system also features a robust control system to enhance safety and performance, safeguarding critical components and ensuring reliable operation under various conditions. To maximize efficiency, proper handling and maintenance protocols are essential. This includes meticulous storage in a clean, dry environment to prevent corrosion and maintain component integrities. Lastly, adhering to a structured maintenance schedule aligned with industrial standards is crucial. Routine inspections of fuel cell, control system, and water management components help identify and address potential issues proactively, enhancing overall performance and reliabilities. Traditional gasoline-powered mowers emit harmful pollutants such as CO, NOx, HC, and particulate matter, significantly impacting air quality and health. In contrast, fuel cell mowers produce only water vapor and heat, offering a cleaner alternative that improves air quality and reduces health risks associated with poor air conditions. Looking ahead, technological advancements including AI and machine learning are enhancing more efficiency and automation. Fuel cell systems, especially PM technology, show promise for their efficiency and zero emission characteristics with pure hydrogen fuel. Despite current cost challenge, ongoing research suggests cost reductions, making fuel cell mowers increasingly viable. Regulatory trends such as California's ban on gasoline-powered lawn equipment from 2024 are driving demands towards electric and battery-powered alternatives, further supporting the growth of sustainable mower solutions. Consumer preference for eco-friendly options are also fueling market expansion, particularly in robotic mower segments. That's all for our presentation. Thank you.